So I wanted to explain to you how you're going to discover what this vertex form is all about and how it helps you to graph. And so in order for you to discover it, I wanted to show you what I'm expecting you to do on the next few slides. For each of these, you are going to use the Desmos calculator provided for you in the Nearpod, and you are going to type in your two equations here. Now, the reason why we have two is because this right here is always going to represent the parent function. Remember how we talked about the parent function on the previous slide? Which gives us the points 0, 0, 1, 1, and 2, 4. Remember that we just plugged in 0, 1, and 2 to get these values that go along with it. We can also reflect them across. So here are the parent function points. And what you're going to do is you're going to try to track these points that make this parabola here. I'm going to make these points really big so you don't lose them, but draw the parabola here. And I want you to compare what happens to your parabola when you view this equation alongside of it. So let me show you how I would do it in the Nearpod. So you will first type in your parent function, y equals, and then x, of course. To get the square, you can either use, I don't know where it's at actually. There is a place that you can type it in, but I always use the shortcut, which is the shift button. So shift and then the number 6, which gives you the caret, which is above the 6, and then put the square in that way. To get out of the square, you push the over arrow. So that's going to give us this graph here. Now notice that my graph has 0 and then 5 here. This is the best viewing window that you can make because this means that each block then counts as one unit. If it's zoomed out for some reason, you'll see the first number being like a 10, or if it's zoomed in a lot, you're going to see maybe a 2 or something different. I would zoom in or zoom out depending on what your graph looks like until you get to this right here where you see a 5 as your first number on the axis. That will allow you to view these the best. Now, the second equation that we had was y equals x to the 5th. I'm sorry, to the second, but it was plus 5. My bad. What the heck was I thinking? And so we can see this new graph compared to the old one. And you want to track what happened to the vertex. You want to track what happened to this 1, 1. Remember that there's a point 0, 0, 1, 1, 2, 4. Those points right there. What do you think happened? So maybe here's the vertex here. Well, here's the new vertex. It's right here. So what happened? What do you think happened to this parent function? What does the plus 5 do? What do you think it does? And then here's the 1, 1. Well, that point, one block away from the vertex, is up here now at 1, 1, 6. So what do you think happened to that point? Is it the same thing that happened to the vertex that happens to that point? And what about this old point 2, 4 right here? Well, 2, 4 had to have gone somewhere. So it was at 2. Now we're 2 blocks away from the vertex. Now it's here at 9. So what do you think happened on this graph? And you're going to then make a comment what you think actually happened based off of what you're seeing here. I'm going to give you a series of different equations. So maybe I say, well, what happens whenever you do minus a number? Well, see, there's that new graph right there. What happens whenever you, let's do add 8? That's interesting. What happens when you add just 1? So are your conclusions going to be the same? Your conclusion should be the same based off of where the number is in your equation. For the next graph, I'm going to give you something similar to this. Notice that is wildly different. The 5 is now inside of the parentheses. There's parentheses, like it's crazy. But I can still do the same thing in my graph. And I can then instead type parentheses, x plus 5 parentheses to the second power. And here's what it does. Interesting. Well, what happens if I change this number? What if it's just a plus 2? Oh, look where it's at. What if it's a minus 6? Wow, that's interesting. So I want you to play around with what happens when you change the number inside of there. And then you're going to decide what you think is happening to the parent function based off of the number that I give you. So notice that a plus did something. A minus did something similar, but a little different. And when I didn't have parentheses at all, remember how it shifted totally different. Look at that. It's totally different than what I had just showed you with the parentheses. So there's something going on here with where the number is in reference to your parent function. You'll also see that later on we're going to do something like that. And notice how the red, the parent function, compares to that other graph. Well, what happens if I make it bigger? Ooh, what did that do? What about if I make it even bigger? Okay. How does it compare? What if I made it a smaller number, like 1/4? Ooh, okay. So you're going to discover what happens with these graphs. Okay.